All right, well, good morning, everybody. Welcome to this session on discussing encryption requirements as they pertain to IBMI. My name is Robin Tatam. I'm the Director of Security Technologies here at HelpSystems, and it's certainly my pleasure to be able to join you today and talk about some of these topics. It's certainly something that is a common conversation nowadays, and I'm sure many of you are encountering it, which is why you're probably here. But certainly if you have anything specific that you want to know, please feel free to send us those questions in the control panel, and you can do a drop down there into the questions area and send those over to us. I know most of you are probably familiar with HelpSystems, but in case you are new to this conversation, we are the provider of the premier security products for IBMI. We refer to those as the Powertech products based on an acquisition we did almost a decade ago, actually over a decade ago now, that has been, of course, incredibly enhanced and expanded since those early days, and definitely an area of focus for us. That's an area that I represent, but I'm also joined by several other colleagues, Carol Wood being one of them. I'm sure a lot of you know Carol's name. She was the IBM security architect for many years at IBM, and she provides an array of services on the IBMI and AIX platforms on the Power servers. We're also a member of the PCI Security Standards Council. We also educate auditors, provide CPE credits to them for their education on auditing IBMI, and I'm also the publisher of the annual State of IBMI Security Study, or I should say one of the authors of that, and that's something we've been doing now for many years. In fact, the first edition of that study was released all the way back in 2004, so we have some really unique insight when it comes to knowing how you guys are securing or perhaps not securing the system. So here's my agenda. We're going to start with just some 101 on encryption, get you guys up to speed on some of the terminology and concepts that you've probably heard about and need to be familiar with when it comes to this conversation. We're going to talk about some of the mandates that are requiring or at least recommending data encryption as part of their base requirements. We're going to have some discussion around the fact that, especially as it pertains to IBMI, not all encryption solutions are created equal. I'm not talking about commercial solutions. I'm talking the approach we take for encryption. And it's important to understand some of the approaches that I think many people lean towards and the pros and cons of each of those. We're going to talk about the traditional methods that people have leveraged for field encryption. In some instances, those are still valid today. If you are, for example, a software vendor, you might have a slightly different approach than somebody who is an end user customer. We're also going to talk about a more modern IBMI encryption methodology and the significant benefits that may come from that to see if that perhaps is a matchup for what you are interested in or what you're trying to accomplish with your IBMI data. We're going to give you some considerations, key considerations. You'll hear that pun probably more than once today. The most important thing in encryption for many of us, of course, is the key. So we drop that key term in there often, but really considerations come down to what you should be thinking about when you are approaching an encryption solution for IBMI so that you have some key takeaways there. There you go, there's your pun, for deciding which solution might be best for you. And I've got some time at the end for Q&A. If you do have questions, like I said, please fire them away to us through that questions selection under the control panel. The first thing we have to understand is what data actually needs the protection afforded to us by encryption. Now, you could argue that these things are eligible for any type of protection because they would be deemed sensitive data. And it could be certainly something that's regulated, mandated, credit card numbers, social security numbers here in the US, national insurance numbers internationally. These types of things, I believe, are pretty well understood as items that need to be protected. But there's also many other things that might be unique to your organization or your line of business, and that could include any type of secret recipe or unique customer list that you might maintain that, if fallen into the hands of a competitor, might be challenging, or if published publicly on a website, that could potentially be embarrassing. So anything that might be unique or confidential, anything that will be deemed regulated, all of these things would benefit from, and in many instances are mandated to be protected through not only hardening of the server itself, meaning that we want to make sure that the server is configured correctly with all of the controls that it has, but that we go beyond that we provide some masking of the data, where we're not necessarily hiding the fact that the data exists, but what we're doing is changing its human readability. So that's where we talk about encryption, which is really just simply the process of encoding the standard information to protect it from unauthorized viewing. And again, what we're doing is hiding the meaning of the message or the relevancy of the data, but not the fact that it does exist. So we're not necessarily preventing somebody from reading the data. What we're doing ideally is preventing them from being able to interpret it. This data is going to be encrypted using some form of encryption algorithm, and these things have existed since the dawn of time. The output created by that algorithm is typically called ciphertext. And here's an example: the quick brown fox jumped over the lazy dog. And if we encrypt that, then of course the data is still visible, but it is not readable to you and I. This encrypted message, of course, needs to potentially be decrypted, but only when the user has the appropriate key. Just like a standard lock, we want to make sure that it is available when necessary and when authorized, but not to somebody who simply stumbles upon it. This decrypted value is typically called the plain text. Now, there's some variances on those names, but I think they're pretty intuitive. Plain text, readable text, ciphertext, really just referring to the ability for you and I as human beings to be able to recognize the meaning of the information. There's many encryption terms that you will come across if you do any type of internet search or do any reading, but there's a few here that I just wanted to point out. First of all, we talk about a cipher, and this in essence is a pair of algorithms that are designed to perform the actual encryption and decryption function. Some examples of this are AES or triple DES, Blowfish, and Cas5. Now, really, these algorithms are grown and retired over time. In fact, some of the older ciphers really shouldn't be used at this point because the computing power and the effort to crack these algorithms has exposed that they are vulnerable to abuse. Typically today, the AES 256-bit is probably the one you hear about most. This is been sanctioned by NIST, the National Institute of Standards and Technologies here in the US, and really is the de facto algorithm used commonly by the US government. The key, I mentioned that this is what's going to actually control the actual cipher algorithm itself. And the ciphertext is going to be managed or manipulated by that key. And a key is represented by bits. And that's what we kind of see when we talk about the strength of the key. It's really the number of bits that are going in to represent that key. And the number of bits, the greater the number of bits, typically the stronger the key. There's two types of main key cryptology, symmetric and asymmetric. Difference being, symmetric is where we, in essence, leverage one single key. You have to keep it secret, of course, because if you have the key, you're going to be able to decrypt. So in essence, the person creating the ciphertext and the one who is decrypting the ciphertext are going to leverage that same key. The challenge with this, of course, is how do they exchange the key in a secure manner that somebody can't intercept it and therefore now have the ability to decrypt that data, which is one of the flaws of symmetric key cryptology. Now, there are ways to ensure that that handshake and that key exchange is done in a secure manner, and that's kind of evolved out of the recognized need of the fact that the key has to be handled with kid gloves. The flip side of that same coin is asymmetric key cryptology, and that is where we're handling key pairs. You may hear reference to a public key and a private key. In essence, the public key is used to put the information into an encrypted form, and then the private key is used to decrypt the information. So in essence, the only person with the secret data, the secret key, is the person who's decrypting it. It's important to understand the definition of a strong encryption key, or strong encryption in general, does change over time. And again, it really comes back to the fact that as computing power has increased and the length of the keys were deemed to be insufficient, we've had to evolve our definition of what really comprises strong encryption. It's going to be influenced by a number of different factors. I've got three key things, or three primary things here. I got to stop those puns. The choice of algorithm, of course, as I mentioned, DES and triple DES was once considered kind of the de facto standard, but it was cracked, and it's relatively easy to do that, especially with just regular DES. Triple DES is basically that encryption algorithm applied 3 times over. The length of the key, as I mentioned previously, is extremely important. And then ultimately, whether the key is maintained securely is extremely important, because it doesn't matter how strong your encryption algorithm, it doesn't matter the length of the key if somebody is able to get their hands on it. The recommendations we have are to use industry standard encryption algorithms. Like I said, AES is considered pretty much the go-to at the moment, and we want to make sure we're utilizing sufficiently strong keys. Now, like many things in security, we have to be careful about how we define the word strong. When we talk about privileged users, for example, we have to define, what does privileged mean? And there's no dictionary definition, in essence, for an IBM profile and what deems them powerful. Same thing with encryption keys. There's really no fixed definition, because this is part of what evolves. At the moment, AES 128-bit keys would be considered pretty secure, although a lot of us exceed that and go after at least 256-bit keys. Now, if you're thinking about encryption, or if you're doing encryption, you can certainly give me that feedback. I'd be interested in whether this is something you've embarked on already, whether you're looking at it, or whether you're just generally interested. But for many of you, I do know that part of what is prompting the conversation is the fact that we have these regulatory mandates that are in essence telling us what we have to do. Now, the first one we have here is GDPR. GDPR is a general data protection regulation. It is a relatively new mandate born in the European Union. It was given a 2-year runway, but has now become legally effective as of May of 2018. On your radar, perhaps, even as a US company, because it really applies to anybody who is maintaining data about individuals, in other words, humans that reside in the European Union. So if you're a global organization, or if you have a branch office or something that is based in the European Union and you have employees that reside there, there's a very good chance that GDPR pertains to you. Certainly a lot of attention being placed on GDPR based on the incredible fine structures that apply there. Potentially up to 4% of global annual revenue, not profit, but revenue for a company, can be levied as a fine under GDPR. So we're all kind of waiting. We're in this honeymoon phase right now since GDPR was enacted, but certainly people that are dealing with GDPR are looking for every tool and mechanism that they can leverage in order to ensure that their data is protected, even if there does happen to be a data breach, and encryption is a great thing to do there. We also have PCI, the Payment Card Industry's Data Security Standards Specification. In essence, this is a mandate laid down by major card brands in order to protect the credit card data that many of us are collecting and processing. So this is really the industry intent to ensure that there is less credit card fraud. Here in the US, we also have HIPAA, which is the Health Information and Portability Accountability Act. This is a government regulation that is designed to control patient and personal health information. Now, I mentioned GDPR first. Let's talk about that a little bit. There's a couple of articles that bring up encryption here, and you'll be glad to know I'm not going to read this verbatim here. You guys can do that. But in essence, encryption is the main technology that's going to help ensure that those huge fines that I mentioned are not being levied in the event of a data breach. How are they doing this? Well, GDPR specifies that technology solutions must be in place to ensure that data is protected. It doesn't really specify a particular solution apart from the fact that if encryption or pseudonymizing the names and database elements is performed, there can be some alleviation from the reporting requirements. So GDPR states that if there is a data breach or even a suspected data breach, the supervisory authorities must be notified, in fact, within 72 hours. And if there is a high risk to the people whose data has been breached, then those individuals must be notified as well. All right. Now, GDPR goes on to state that if the data is not encrypted or is masked in some way and the keys are not stored with the data, then the individuals don't need to be notified, because in essence, if that data is encrypted, the data is deemed unusable. Now, bear in mind that that can change over time. So if initially there is no requirement to be notified, but it is later determined that the keys are even suspected as having been compromised, then of course the notification requirement kicks back in. Under PCI, again, it's pretty explicit. We have to use strong cryptography, which means 128-bit or greater here under PCI. So that kind of comes back to that definition. But in essence, what we need to do is render the primary account number as being unreadable wherever it is stored. And that could be inclusive of portable media, backup media, or of course, any logs that are being generated. And this protection has to be done through some of the mechanisms that we've listed here. So many mentions within PCI of the necessity and benefits of storing this data in a form that if somebody were to access it without permission, that they are unable to actually read or leverage that information for personal gain. Well, HIPAA is pretty clear here. Encryption and decryption have their own little section here. Implement a mechanism to encrypt and decrypt electronic personal health information. So they really break this down into that basic form of if you have electronic personal health information, you have to have something to encrypt and decrypt it. And we have to also acknowledge the breach notification being required when any type of unsecured PHI is going to be exposed. That includes individuals that were affected by a breach. It includes media outlets as well as the government watch body. Now, this encrypted data is considered secure. It doesn't fall under those requirements to notify of a data breach. So again, we're getting some benefit not only in the protection of the information, but also in the fact that we alleviate some of the notification requirements. But wait, there's more. They're not the only regulations. In fact, many of them today speak to this benefit. The New York Cybersecurity regulation is relatively new. This is handled by the Department of Financial Services out in New York State here in the US. And again, they have a section speaking to the encryption of information that should be deemed non-public. Now, the DFS is regulating organizations in the financial sector, and they recently responded to the increase in cyber threats with these new requirements aimed to minimize the financial damage potentially caused by data breaches, and of course with the target of preventing data breaches from happening, and encryption is just simply part of that. The law covers here all entities operating under or required to operate under a license, registration, charter, accreditation, or similar authorization from the New York DFS under the banking laws, insurance laws, or the financial services law. So again, really throwing some legal terminology in here, but while there are some narrow exemptions, really what we're trying to do is ensure that all of this data is stored and protected in any type of breach scenario. And the thing we're seeing here with the DFS cybersecurity regulation is that it's being adopted elsewhere in the country. And so even if there are branches that perhaps are in New York and there are hundreds of other branches elsewhere, the law still applies. So it really is going to be applicable to anybody, even if the footprint that they have within the state of New York is relatively small. When it comes to IBMI, we really have three areas that we want to talk about and how this impacts IBMI. First is database. Now, these databases are accessible in many instances through tools that we have simply on our PCs like Excel and Crystal reports. We, of course, have native tooling, things like copy file, query, web query, display physical file member, DFU, all of the tools that we've grown up on the platform and leverage for many instances really here are impactful when it comes to the ways that data can be abused, and we've got to make sure that's protected. When the information is sent to media for disaster recovery purposes or data exchange purposes, we often find that that is a source of abuse. The tapes get lost or stolen, and we find ourselves in an unfortunate situation. Here we have to acknowledge that sending data to media is the possible risk point for many of you, because at that point it has left the confines and protection of the host server, and all of a sudden now the data is out in the wild. So we've got to make sure that if it wasn't in an encrypted form while at rest in the database, that we ensure that it is placed on the backup in a protected format. It's rare to find systems now that are not communicating with others somewhere, either on the network or potentially across an intranet or outside of the network across that dreaded internet. Anytime we communicate across these mechanisms, we should ensure that that data is traveling in an encrypted form, and that can be done through encrypting and using encryption protocols to protect those transmissions. One of the things that I try to instill in people is that encrypting data on an IBMI platform certainly is a possibility. It's also potentially easier than you think. There's a lot of preconceived notions about the complexities of encrypting data and the impact. So we have to acknowledge that it can be easier than you think, and we talk about some of those pros and cons here in just a moment. It's relatively easy also to prove you're in compliance. If you can show that the data is stored in an encrypted form, that the encryption process is strong and well designed, and that the data is only readable to those that should have readability, is going to make that relatively easy to prove. What we have to recognize is that the way we encrypt data, the methodologies we use, were not created equal, at least as it pertains to IBMI. And we have to understand, as I said earlier, the pros and cons of each of those approaches. So let's jump in and talk about really what the differences are and some of the things you may have heard about in the pros and cons of each one. Now, to understand the encryption process, we have to understand where potentially the impact is going to be on our host systems. So the first thing is the fact that in most instances, or at least previously, when we were doing encryption of data, there was an impact on the actual database itself. So here I have a social security number field. In my instance, it originally started as a 9 numeric field, and the data, as you can see, 1, 2, 3, 4, 5, 5, 6, 7, 8, very readable if that was a legitimate social security number. Fortunately, it's not. So we transition this field into an encrypted form. We know the social security number is a target for criminals, and so we want to make sure that's stored in an encrypted form. Two things are going to impact us here. Number one, the encryption is going to potentially leverage a different character set, meaning that when we have this data in an encrypted form, it may not now be limited to the digits 0 through 9. And so we have to alter the field structure to not be a numeric field, but actually to be an alphanumeric field. Most encryption algorithms also impact the length of the field. So when we go from, for example, a 9-numeric field, we may go up to a 16 alpha or even longer field needed in order to store that data. So we've got two potential changes here to an existing field. Now this has, of course, a pretty significant and domino effect on potentially to the application. Anytime you make a field change in a file, there is implications. Simply recreating the file, recompiling it, we've got to extract the data because recompiling it will flush the data from the file. But that's a relatively easy hurdle to overcome. What might be more challenging is to seek out and potentially modify any time that field has been referenced. If you were around for the Y2K projects that everybody was scrambling in the months preceding the year 2000, you'll realize that these changes often are not difficult. It's just the fact that we have to find where they need to be done, and we may have lots of places where that social security number in my example has been touched in the application. Now, the code itself, when we look at pseudocode, might be quite straightforward. We recognize that if the user is authorized, then perhaps we call a decryption routine to take that encrypted data in a file and port it into a decrypted or plain text visible view. If the user is not authorized, then perhaps we use some type of masking characters. Right? So there's lots of different ways to do that. Maybe we simply don't decrypt it and we just display that encrypted version of the data. But this pseudocode is really just showing how simple it can be to put that code in, but it doesn't speak to the volume or complexity of modifying the application to be able to handle all the different places that field is referenced. That also assumes that you own or have access to the source code for the application. And if that's not the case, then that, of course, can be a game break right there. All right, so if you're sitting back and you're relaxing like this guy and you're thinking, no big deal, I'm using full disk encryption, then you'll be like many people that have looked at this solution as kind of being the answer. And we have to talk about some of the nuances of this in terms of IBMI to determine whether this is indeed the answer and whether the problem has been solved by this approach. First of all, one of the big benefits of full disk encryption is that it is non-invasive. In essence, what you're telling the system at a hardware level is that the disk stored in the system is going to receive data in an encrypted form. And anytime the database manager reads or writes that data, then it will take care of using hardware encryption to put that information into its appropriate form. There's no impact on the database. There is no impact on the application, which is extremely beneficial and very enticing. Not only is it non-invasive, but the fact that this is often happening using hardware chips inside the disk controller, then we have to recognize that it's also extremely fast. One of the pain points often with encryption is that it has a tendency to carry overhead associated with it. But if this is being done at a hardware level and that it is transparent to the application environment, then we have a significant benefit in regards to not impacting performance. So is this the silver bullet, I hear you ask? Many of you are using full disk encryption for that reason, but here's some things that I want you to consider. First of all, when we talk about a Windows server, I know it's a dirty word to us here in the IBMI community, but we're all using them and they certainly have benefits in their place in the data center. If we have that Windows server, perhaps maintaining 3 drives in the environment, and I'm going to assume that these drives are not just there for parity protection, they are indeed separate drives in the server. And I'll use my laptop as a good example with 2 hard drives here inside it. If I were to remove one of those drives, my system, of course, will potentially function. I can still access the data on the other 2 drives, but I also have the ability to take that drive out of that server and move it to a different one. So I have, for example, an external hard drive attached to my laptop here. It is protected through hardware encryption, but let's assume it's like one of the many USB drives that are out there if you go to your local technology store. They plug in through USB or some type of SATA connection, and the data's there. When I migrate from one laptop to another, which I did earlier this year, all of my documents were stored centrally on this drive. So all I had to do was unplug the USB connector out of one laptop and plug it into the other, and I immediately had access to all of my documents. Now, from a security person's perspective, that's not a good thing. The ability to take a drive and plug it into a different server definitely leaves us somewhat exposed if I were to perhaps steal a drive or turn a drive in because it's now full and I didn't correctly degauss or wipe out the contents of that drive. I have to have concerns about that. Now, when we contrast that to IBMI, what we see is more like a Jackson Pollock painting, meaning that IBMI scatters all data across all available drives. Now, it's not just doing this for protection purposes, it also does this for performance purposes as well. So this disk balancing is typically automatic, and it's rare that you would ever find entire objects on one single disk. But let's assume for a moment that you did. You have to understand that one of the requirements for IBMI when you install a new disk is that you turn around and reformat that disk. You have to register it so it's available for use by IBMI. So even if you were able to take a drive from one IBMI system and move it to another, then you have the protection of the fact that before that drive could even be read, it has to reformat it. I'm not suggesting that the NSA or some other government agency with questionable abilities to read protected information couldn't extract data from those drives, but the reality is the most common type of abuse is that somebody's going to insert that drive into another server, and we have to recognize that it would only be readable to a power server, and installing it in there has to involve the re-registration of that drive. The big issue for me with disk encryption is that there is no differentiation between authorized access and unauthorized access. Anybody with a profile on IBMI, whether they were granted that profile or whether they obtained it, is going to have the same level of access, in essence, to the database information. Now, I totally understand and acknowledge that the IBMI security controls will influence what objects I have access to, but not necessarily which data elements within the objects. So I can't do anything selectively, regardless of whether I'm the good guy or the bad guy, whether I'm using a tool like Copyfile or Query, or I write my own RPG program. The database sees the request coming from the user, and assuming that they have object level security, they're going to be handed the plain text version because the disk controller is going to serve up the decrypted version of that data. It doesn't make any differentiation. If you're leveraging disk inside the chassis of the server, typically referred to as internal disk, then I would argue that this is giving you minimal protection. Granted, it may be enough to get you the compliancy stamp. You are encrypting data, but I will tell you that the benefit that you're gaining, the ability for someone to have read that data, is not really there. And so we have to acknowledge that this may not be sufficient. Now, in contrast to internal disk, many of you are using external disk. Storage area networks, good example, where the actual physical disk units are in a different geographic location to the server itself, and they're connected through some type of pipe. Now, when we use encryption of full encryption of disk, we do have now protection of the data from when it leaves the disk controller inside the chassis to the actual physical disk unit itself. So in the case of external disk, there is a benefit here, but it's not the protection of the data from unauthorized reading. It is protection of somebody intercepting that flow of data and being able to process it, because if they receive the data from the disk controller, again, it's going to be unreadable. All right, so we've been doing encryption for thousands of years. We've been doing encryption for many years on IBMI, and as old as many of us in this community are, certainly not thousands, but the box has been around 30 years in some form. And field encryption has been a discussion for many years, and that desire to protect that information. So we kind of break this down into pre 7.1 and post 7.1. Previously, prior to 7.1, you really had two main options to utilize database encryption. One was to leverage some APIs that are in the operating system in order to encrypt data before the writes, and then decrypt data before the reads back. Now we can use column triggers to automatically encrypt that data during the writes and the updates, but not necessarily the reads. So column triggers were a way of simplifying that. We'll talk more a little about triggers in a moment. We still had to leverage APIs even when we had triggers, because decrypting data doesn't allow for the trigger to change the data, because in essence that could be a security risk. Anytime the actual data element is read, if it was modified and always presented to the user in an alternate form, we may think that it's actually stored in that manner. Previously to 7.1, we had to modify the database in the ways I've explained, potentially changing the field type as well as the field length. We could potentially use an external file. Sometimes this was called a shadow file, where there was some kind of index placed into the original file, and then the encrypted data was stored in a new file that was generated purely for that purpose. And that is beneficial in many ways, but again, has influence on the application layer, because it has to now potentially read that shadow file. You also had limits on what could be encrypted. If you're using timestamp or date time fields, they were not possible to encrypt. And if you're using any binary large object types, that was also a restriction as well. So let's talk about APIs first. The big downside for me is that it's very invasive. It is not overly difficult. It's actually very fast and efficient, but the requirement for us to have to change the database, and the requirement that that has then to update the application, is a real issue for me. Now, I was fortunate and certainly very honored to be part of the team that wrote the IBM Redbooks publication on data encryption for IBMI. And at that time, we were dealing with v5.r4. We were just getting a peek into v6.1. And certainly the API approach was really what was being heavily leveraged there. Now, don't get me wrong, these APIs are extremely fast and efficient, because we only have to invoke them when they're needed. So if we're touching a field, we're reading a file, but we know we're not actually doing any display or calculation on the protected data, we don't have to decrypt it. So it's not an automatic thing. Unfortunately, there's no real integration with the DB2 types of tools that are out there. So if you have the encrypted stored in the database and you try to run a query or an SQL statement, it complicated things, because users weren't going to have readability of that database, even if they were authorized users. For me, the API approach is most applicable to a software vendor, where they're writing their application and they're selling it or installing it in multiple places, in which case the investment of adding the APIs into their application is much more effective. To me, the API approach is not geared towards end users or end user shops that want to take either a legacy application or an application they may not have source code to and utilize encryption. All right, so let's talk about triggers and how they influence things. Again, we have the potential of an invasive change to the database. We still aren't getting around the fact that the structure of the file, those fields now have to potentially be alphanumeric and longer. Now, at that time when triggers became a thing for encryption, you heard many people touting the fact that it eliminated the coding requirements, because the trigger would be invoked outside of the application and handle all the encryption functions. But to the layperson, when they hear the term encryption, what they're thinking about is the entire process. But technically, encryption is a one-way process, where we're taking that plain text and turning it into the ciphertext. If you want to take it the other direction and return it to the readable form, we're now talking about decryption. So there's a slight technical difference there. And while the trigger can handle the encryption relatively seamlessly and outside of the application, there was a requirement anytime we did decryption that we had to find another way. That took us right back to square one. meaning that we were changing the application and had invasive requirements there. Again, no integration with other DB2 tools for the most part. If you wrote a query, for example, again, we weren't able to automatically display that data to authorized users. And the biggest pain point, arguably, is that triggers are pretty slow. So the impact from a performance standpoint was noticeable. So where do we go from there? We've talked about the ways you can encrypt, and unfortunately, there are some significant downsides to using those. But starting in version 7.1, life got a lot easier for many of us. There was a new function added into 7.1 known as a field procedure, or often referred to as a field proc. This is something that is non-invasive to the database, which was dramatic in the benefit that it brought to the table. Now we can indicate that a social security number that is 9-numeric is going to store encrypted data, and under the covers, the database handles the fact that when that data is actually stored, it potentially will be in a bigger alphanumeric field. But to us, as the users of IBM I, we don't have visibility to those behind the scenes functions, so we don't have to worry. To us, it still looks like a 9-numeric field. We're going to let the database manager handle all the complexities of what's involved there. So very, very seamless to the database. That, of course, had the same domino effect in a positive way to the application. So many instances, the application doesn't need to be changed either. And I'm talking about not only encryption, where we're going to the ciphertext, but I'm also talking about decryption, where we're turning it back into the human readable form. All of these is integrated within the OS function. So regardless of whether you're using copy file, display physical file, query 400, whether you write an application program in COBOL or RPG, all of these things are going to invoke the field procedure because in essence, it's being invoked by the database itself. The benefit of a field procedure is that it is a defined function that is programmable, meaning that we now have the ability to make decisions about the encryption and decryption functions. Now, bear in mind, IBM I 7.1 was born in 2010. We're now 8 years later. It has indeed been retired. So if you're on IBM I and you're on a release earlier than 7.1, not only you're unsupported, but you won't have field procedures at your disposal. So hopefully most of you, if not all of you, are already running on a release that has this functionality built into it. The thing to bear in mind with field procedures is that they are not an end user function. It's really more of an enabling technology, and that's pretty common in IBM I. If you've done anything with the network exit points to manage FTP access and ODBC access, you have the same concept in mind here, where IBM has built the infrastructure, the foundation that we need, but they don't provide the end function, and it's the exact same with field procedures. We have the ability to invoke a program from the database, but that program doesn't come provided by IBM, and you just activate it. The big benefit of the field procedure when you do provide the operating system with that end function is that we have the potential now to minimize or even eliminate application changes. Now, I say minimize because there can be some influence. If I was sorting or searching on that social security number, and that database element is now stored in an encrypted form, of course, the characters are different, the order may be different, and how do I find a match? Well, in fact, we're going to talk a little bit more about that capability here in just a second. The operating system stores these encrypted values for fields behind the scenes. We don't have to change the data tape. We don't have to change the lengths. We don't have to change the CCS IDs to that database file. The support is there for both regular traditional physical files based on DDS described elements, as well as if you're using SQL defined tables. So if you're using a more modernized application and everything's been defined through SQL, you can still use field procs. You can have a field proc on multiple fields in a single file. So if your file contains more information than just social security number and you want to protect multiple elements, you can attach a field proc to each all of those fields. We don't see as much of the multi-member file structure as we did when we first migrated from the System 36 environment, but the concept here is that a single file or table can contain multiple subsets. Now, field procedures work in that instance. If you are using multi-member physical files, you're probably aware of that because there are development considerations for that, programming considerations. So you're most likely going to be aware of that, but field procedures can be used in that instance. So that, again, is an inclusive way for you to use encryption capabilities. As I mentioned, these field procedures are running at the database level. In essence, what's happening is anytime there is an insert or an update to the database manager will handle the encryption function by invoking the field procedure. Then when that database receives a request to extract that data or read that data from the file, the database manager, again, will invoke the field procedure to determine whether that field should be decrypted, and if so, to actually perform the decryption routine and provide that data back to the user. These field procs are going to be invoked anytime there is an insert, update, or read operation. If you're an RPG person, that means read, add, update, or delete, and that's all automatic, again, within the database. If you wish to add a field procedure to a file, there's a couple of ways to do it. You can leverage some SQL syntax. If you love using SQL, this is the way you want to go. In essence, what we're going to do is issue an alter table statement to indicate to the file that we're going to make a change. We're going to alter a column, which in essence is the field name that we wish to attach the field procedure to. And then we define the name of that field procedure, which is a high-level language program, in the library where it resides. Some considerations, of course, you can't have any other locks on those files while you're running that alter table statement. You have to also have some special authority to the file, the alter object authority, and you also have to have the ability to use the field procedure program. So we're not going to simply trust anybody to attach a field procedure to a file. You have to have the necessary authority to the file as well as the field procedure program itself. When you attach this field procedure, the database manager is going to go through and perform a mass encryption of all of the values in that column. And that's certainly a consideration if that is a big file. You're going to have some downtime for that file. Granted, it should be just a one-time process, but you're going to want to submit it to batch so that it has plenty of opportunity to run. If you want to remove a field procedure, then you're going to, again, use that alter table directive. Again, this is going to perform a mass function. In this case, it's going to decode all of the values that are currently stored in an encrypted form. If you want to see the encoded values, meaning the encrypted data, then we have to leverage a select statement within SQL. Now, the display physical file member really is something that has limited use here because, as I said before, the encryption is in the database level. So if somebody uses display physical file member, it's not going to just simply show you the decrypted data unless you have permission to it. So you're either going to see the fully encrypted version or you're going to see the decrypted version. But if you use the hex encoded directive within your SQL statement, then you will actually see the encoded value instead. So what invokes a field procedure? Well, these are the things that will cause it to be invoked during an encode activity. As I mentioned, if you're using COBOL or RPG or some other high-level language program that is doing native record-level updates or writes to the database, the field procedure will be invoked. Likewise with SQL, if you do an insert or an update to impact the database, that will see the field procedure being invoked. And of course, many of the CL commands that we leverage under copy file, reorganize file, start DFU, all of these utilities that we have leveraged for many years to go directly against the database. Now, if you're using query, as many of you I know are, and you are in essence running a query that will select particular records out of a database file, and you indicate that you want, in this case, a social security number that matches 508.77.32.11, then what happens under the covers is the database applies some smarts here. It will encrypt the search algorithm and then perform a match against all of the encrypted values in the table. And this leads to negligible performance implications, which is fantastic. Same thing on a chain operation in a high-level language program like RPG. Again, because we're looking for an equal match, the operating system says, I'm going to encrypt the search algorithm and then do the match on that. If, however, you are using other types of comparators, we may have some challenges. Now, on the decode events, we have many of the same things. If we're doing a read equal, a chain, an RPG, any of those things will invoke the decryption function portion of the field procedure. Same thing with your SQL. Query processing, same thing. Now, I've got it listed under decode events here, but it's really true under both. If I use, for example, a greater than when I'm searching, I have to recognize that there is no way for me to really do that comparison against data that is potentially in, or most likely in, a different order. In this case, the database manager will do a mass decryption of that column of data and then perform its match to return the values. And as I'm sure you can imagine, if there are thousands or even millions or billions of records in that table, that select statement is going to take a significant amount of time to be performed. So searching, sorting on encrypted data values is not recommended wherever possible. Other decode events are listed here. That includes FTP, display physical file member, and again, even if there is trigger processing, it will also invoke the field procedure. So let's talk about some considerations here if you are thinking about or evaluating encryption solutions. For me, of course, one of the driving factors is a compliance regulation. So if your goal is to comply with a regulatory mandate, then you want to make sure that your solution is going to accomplish that for you. You want to make sure that the encryption algorithm and the key strength is going to be sufficient. We want to make sure that we pick a solution that has some timeliness associated with it. We're not locked into one algorithm that has been around for 20 years, only to find that it's been deprecated by one of the regulatory mandates, and we have to now select a new solution. We want to make sure there's an audit trail being generated. Who's generating keys? Who's changing the keys? And potentially who's even decrypting data? Most people are very gun shy about encryption routines because they're concerned about how long it will take them to transition from the open database they have today to storing data in an encrypted form. So how that is accomplished is important and has influence over the overall implementation time. We want to make sure, of course, that our solution is going to be easy to use. We don't need something really complex that's going to provide a significant learning curve. This should be straightforward. I've just spent the better part of an hour talking to you about the fact there are pros and cons, but that this is possible in IBM, and it can be easier than you think. And so we want to make sure any solution that we choose carries that mantra forward. And of course, when it comes to encryption, we want to make sure we have good support. What happens in a disaster recovery situation? What happens when it comes to handling your key support? Do you do split keys? Do you do key rotation? Having people that are accessible, that have good knowledge of these requirements and processes and support of that application, of course, is extremely important, just as it is with most third-party applications. So just for a minute or two, I'm going to wear a commercial hat here and introduce you into HelpSystems IBM encryption solution. It is a tool called Crypto Complete. This came with a fantastic acquisition that we did of Linoma a few years ago. So if you know the name and you think, well, that sounds familiar, it is in essence the same fantastic solution, now rebranded under the Powertech name. And so the brand is different, but the tool is still just as comprehensive as it's always been. It's going to leverage either field procedures, or if you prefer, you can do those triggers in order to ensure that the data is stored in an encrypted form and then provided back to the user as appropriate. The good news is no application development is typically required, and not only in your own application, but to generate or build those field procedures. Remember I said IBM provided us with an enabling technology. So what is HelpSystems doing in this equation? Well, we are auto-generating the appropriate field procedures and attaching them to the files and the fields that you've told us you wish to have encrypted. So behind the scenes, we're doing all of that heavy lifting. The beauty of this solution is that it incorporates all of the key handling as well, and also will give us the ability to conditionally decrypt the data, meaning that some users may be able to see the full plain text version, where others may perhaps only be able to see the last 4 characters of that number in order to make a determination. So the main bullets here, we do have some policy settings that supports PCI, for example, dual control of key creation, separation of duties under Sarbanes-Oxley. We have integrated key management built in. So you don't have to have a third-party external key manager, but if you do have one, oftentimes we can integrate with those and you can leverage that same technology for IBM. We define within the software who can manage the keys, who can perform encryption and decryption, who can see clear text or plain text versions of the data, and who can see masked versions of the data. And all of this is handled outside of your own application. We're going to leverage and make available to you the standard algorithms that we should be using, and all the way into the future through AES 256 has no foreseeable end of life at this point, and is a great option for those of you that can use it. What we're talking now is database field level encryption. We're going to handle all of the fields and the definition of those in a field registry so that we can indicate to the system which fields we want to have handled by the field procedure. As I mentioned, we automatically assign that to the database behind the scenes. We generate the field procedure under the covers, so there's no development effort in order to do this. And thanks to IBM's infrastructure, we can now support most field types. So pack numeric, date fields, things like that, which were a limitation before, are no longer a restriction. And if you have small or large fields, we can handle those too. But database is just 1/3 of the element here. We also handle encryption of files in the IFS, as well as those all important backup tapes. This is a full in-the-box solution. The management, as I said, of the keys is all built in. Conditional decryption and masking, as well as dashboards in HelpSystems' new Insight user experience. So if you prefer a graphical user experience with central deployment across multiple partitions, things like that, then Insight is definitely the HelpSystems tool that you're going to want to check into. That is a free tool to anybody who is a HelpSystems customer, because of course it doesn't do anything else without the tools being there. So dashboards are available for the encryption functionality as well. All right. The big thing for me is the minimal invasion required, and in some instances, zero invasion into the application, and it's always zero invasion into the database. This is what it's going to look like as an example inside a user application. Here we see a credit card number, and this particular user has been told they can see the first 2 characters and the last 4 of the credit card number that's been stored. Everything else is masked with the hashtag. That extends out to system screen. So here we have a query that has been run indicating that the credit card number and the customer number are restricted. Social Security number, we've opted to mask with the number 1 here. And so again, we have the ability to show information, fully hide information, or display a partial view using masking. The encryption capabilities here are just part of our entire portfolio. So the Crypto Complete is one of more than a dozen tools that we've designed to address security pain points within IBM, extending from perimeter protection to antivirus, user provisioning, and baseline policy management. So lots of different moving parts and pieces that we bring to the table. So if you are embarking on some security research or discovery, and you're looking for a vendor to partner with, I would offer up that the solution base that we have and the services organization backing that is second to none. If you are new to this, then for me, everything starts with a health check. At the 12 o'clock position, which is of course where your clock face starts, and it's where we think a security project should start, we have a security scan tool that you can leverage and discover how your system is configured. This is a free function that is available to anybody who wants to use it. If you are interested, let us know. Go out to our website and we'll be happy to run that for you. It's non-invasive. It takes only about 60 seconds to run, and your results will look much like the examples on the screen here. So this is not just a doctored view. This is actually a scan that was run. All right, I'm going to see if there are any questions here. I know we're right at the top of the hour, so I appreciate that you guys have stuck with me here. And I'm going to get through just a few of these. I know there's probably more than I have time to answer, so I'll do my best. And if I don't get to your question, please know that I will follow up with you afterwards. All right, so let me just scan ahead here. Okay, Larry's asking, is there an impact to replication by enabling a field procedure? So certainly there's considerations there. You want to make sure that the field procedure is being replicated as well, so any changes there, but this is a database endorsed function. So depending on how you're doing your HA, there may be some considerations. Perhaps if that's a question we want to take offline, you can give us a little bit more information, then we can try our best. But typically there's some considerations there that you want to think about, but we have lots and lots of customers leveraging field procedures in IBM as well, of course, as this is a 7.1 function of the OS that are replicating. All right. Tom, you're asking, what are my thoughts on IBM's option 45 under SS1, the encrypted ASP enablement? That is the full disk encryption that I spoke of. So it's a great thing to do. I'm not saying not to use it. My point is that it is not the silver bullet because it is not protecting you from anything except somebody removing a disk drive or intercepting the flow of data between the controller and the drive. Any user, which is, let's face it, where most of your risk comes from, is going to be presented with the plain text version of that data. So go ahead and use it, but don't use that as a sole exclusive control. Use it in conjunction with something else as well. All right, let's see here. Okay, Brad, you're asking me to clarify a little bit why there's no differentiation between unauthorized and authorized users. What I mean by that is there's typically lots of users on a server that are really not required to access a particular application database. So yes, they have to have a user ID and password. So they're authorized to the server in that sense, but they may not be authorized to the actual application data. Now we can secure, of course, at the file level. We can even now secure at the record level using a facility in version 7.2 called RCAC. But what we're doing is securing the database. If somebody has sufficient authority to get to that object, for example, they're carrying all object special authority, then the operating system is not going to make any determination as to whether it serves up encrypted data or clear text data. It is always clear text. So if I am somebody who's hacked the environment and has gained access through the door using somebody's guest credentials, then if I have all object, then I'm going to be able to see and extract all the data. So that's what I mean by authorized and unauthorized, more so than thinking somebody who is a hacker who has gained access deliberately. All right. All right, looks like that's all the questions. I appreciate you guys hanging with me. Again, thank you for joining. I did record the session, so look for that email from us. If you are interested in a security scan or if you'd like to know more about our encryption solution, we would love to be able to give you some data sheets, show you a demo, or let you run a proof of concept of your own that we'll help you with and get you well on the road to being in a protected form. Again, my name is Robin Tatam. I am with HelpSystems and always available for your questions. I appreciate your customer loyalty as well as your attendance to these webinars. It's always fun to do them. So thanks, everybody. Enjoy your remainder of the day. Bye-bye.